Hi everyone, we are in week 7 of distance learning. This week we are learning about volume, and in particular we are going to be focusing on finding the volume of cylinders, cones, and spheres. So first of all, what is volume? Well, when I searched for the definition of volume, this is the quote I got. Volume is the quantity of three-dimensional space enclosed by a closed surface. For example, the space that a substance or shape occupies or contains. So basically, volume is all the space an object takes up, or you could think of it like all the space inside of an object. So as I said, we're going to be focusing on cylinders, cones, and spheres, and I put some examples of each of those shapes at the bottom of this slide. Let's start by thinking about volume that we do know. So you should know how to find the volume of a prism, and maybe a few other shapes, but you should for sure know how to find this. To find the volume of a prism, we have the formula V equals, we multiply the length times the width times the height. So in this case, our length is 9 centimeters, our width is 7 centimeters, and our height is 13 centimeters. So our volume would be 9 times 7 times 13. Now, I'm not actually going to multiply this out to find what our volume is. However, I do want to point out that the length times width is something you already know. This is actually the area of a rectangle. So, in fact, it's this area right here in the bottom of the prism. What we're doing when we find the volume of a prism is we're taking the area of the base. So in this case with a prism, it's the area of this rectangle. And we're kind of like stacking it on top of each other to figure out if all of these layers were right on top of each other in the prism, how much area would we have stacked up? So maybe that wording is a little funky, but volume basically describes all the space inside of it. So if we know the area of the base, we can stack the base on top of itself all the way to the top of the object and have that whole volume. So what we can do when we find volume, we can look at this volume formula as length times width is the area of the base. So I'm going to use a capital B for area of the base. And therefore, when we're dealing with the volume of a prism, the volume formula is length times width times height, but we could write it as area of the base times height. And this is going to be important as we start learning about our other three-dimensional shapes. So we want to learn about how to find the volume of a cylinder. And over here, I have a cylinder on the side. So using the same kind of idea as a prism, we would find the area of the base, and then we would stack that base multiple times right on top of each other, going all the way up the cylinder until we get to the top to find the volume. So what that means is that for a cylinder, the volume formula is very similar. We find the area of the base times the height. Well, what is the area of the base? The base is a circle, so let's think about what that means. If we look at a circle, you might recall that a circle has a diameter and a radius. A radius is half of a diameter, or you could think that the diameter is the radius times 2. So 2 times the radius equals the diameter. So to find the area of a circle, the formula is A equals pi r squared, and r is the radius. So let's look back at our cylinder. All right, so we said that volume equals the area of the base times the height. and our base is a circle, so the area of a circle is pi r squared, and therefore the area of the base is pi r squared. So to find the volume of a cylinder, we would stack that area, or stack that circle on top of each other to find the volume, and therefore we have V equals the area of the base, which is pi r squared, times the height. And we have the formula V equals pi r squared h. All right, let's try that. Let's do an example problem. Assume the Coca-Cola can is a perfect cylinder with a height of 5 inches and a radius of 2.5 inches. So let's write down the things we know. We know this is a cylinder. Volume of a cylinder is V equals VH. V is the area of the base, and the area of the base, the area of a circle, so V equals pi r squared h. We know R is 2.5 inches, and the height is 5 inches. So therefore, we can substitute this information into our formula. Now we need to use order of operations. So order of operations tells us to do our exponents first. That means I need to do 2.5 squared, 2 and 5/10 squared. 2 and 5/10 times 2 and 5/10 is 6 and 25/100, so 6.25. And then everything that we have here is multiplication. I recommend that you multiply your numbers first and leave pi as a symbol. So we have pi times 6.25 times 5. 6 and 25/100 times 5 is 31 and 25/100. And then we're still multiplying by pi, so we have V equals 31.25 pi. And this is in inches cubed. And even though pi is in our answer, you might recall that pi is a non-terminating decimal. So what that means is that it doesn't repeat, and it just keeps on going forever and ever and ever, because pi is a ratio. And so, therefore, the most accurate representation of pi is the symbol pi, and you can keep it in your answer. Now, if we want to get an actual number, then we could use the approximation 3.14 for pi, and therefore we would see V equals 31 and 25/100 times 3.14, and we get 98.125 inches cubed. Now this might not be the exact dimensions of a Coca-Cola can, so maybe this is not the exact volume, but this is just a great example so you can see cylinders in the real world and see how we can find the volume of cylinders. Let's try some other shapes. All right, so we're going to compare the volume of a cylinder to the volume of a cone. I want you to watch this video real quick. Notice what happens when we put the volume of this cone inside a cylinder with the same height. The cone has the same radius and the same height, and we can fit 3 of the cones into one cylinder. So what that tells us is that the volume of the cone is equivalent to 1/3 of the volume of the cylinder. So, therefore, we can easily write a formula to find the volume of a cone. So, we know that the volume of a cylinder is V equals pi r squared h, and a cone is 1/3 the volume of a cylinder. So therefore, the volume of a cone is going to be 1/3 the volume of the cylinder, which is pi r squared h. So we can say that the volume of a cone is V equals 1/3 pi r squared h, or we could write it all over a common denominator. We could multiply 1 times pi r squared h and put all of that over 3. So these are equivalent, and therefore we have the formula for volume of a cone, V equals pi r squared h divided by 3. We're going to do an example problem. Assume the hazard cone is a perfect cone with a height of 3 feet and a radius of 1 25/100 feet. What is the volume of space inside the cone? Well, we're just going to apply our volume formula. We figured out that V equals 1/3 pi r squared h. We're going to substitute our information. V equals 1/3 times pi. Our radius is 1 25/100 feet, so 1.25 squared, and our height is 3. Again, we need to apply order of operations, so we need to start with our exponents. So V equals 1/3 pi. 1 25/100 squared is 1.25 times 1.25. We get 1.5625. And then we're still multiplying by 3. So let's do this multiplication next. Now we have V equals 1/3 pi times 1.5625 times 3 is 4.6875. And then we have V equals 4.6875 pi, all divided by 3. So 4.6875 divided by 3 is back to 1.5625 times 3.14. We get the volume of this cone is 4.90625 feet cubed. And maybe I might ask you to round it to the nearest tenth, and you would tell me that the volume is approximately 4 9/10 feet cubed. All right, so the last shape that we are going to look at is a sphere. A sphere is like a ball or the globe. So what we know in math is that the volume of this half sphere is 2/3 the volume of the cylinder. So this half of a sphere right here, the whole volume is 2/3 of a cylinder, and the cylinder, remember, is pi r squared h. Well, when we are looking at a full sphere, that means we have 2 halves of the sphere. So the volume of the full sphere would be 2 times 2/3 times the volume of the cylinder, which is pi r squared h. And you might notice that the height, because it's a sphere, is actually also the radius. So therefore, we can replace this h with the letter r because it is equivalent to the length of the radius. And now we have V equals, so we'll multiply 2 over 1, so 2 times 2 is 4, 1 times 3 is 3. Then we have pi r squared times r. Well, r squared means that what we're doing is r times r, and then we have times r again. And this means that we're multiplying some number, whatever the length of the radius is, times itself 3 times. So you might recall that if we take a number and we multiply it times itself 3 times, we can write that with the exponent 3, or we might call that cubed. So we have the volume of a sphere is 4/3 pi r cubed. All right, let's try an example problem. The giant beach ball on the left has a diameter of 9 feet. What is the volume of this beach ball? Okay, so we know that the diameter is 9 feet. We know that the volume of a sphere, the formula is 4/3 pi r cubed. But we're not given the radius, we're given the diameter. And you might remember that the diameter is 2 times the radius. So therefore, if we divide both sides by 2, the radius is half of the diameter. So the radius equals 9/2 feet. Or maybe you know that that's 4 5/10. We could leave it as a fraction. So we're going to now substitute that information. We figured out the radius is half of the diameter. So we have the volume is 4/3 times pi times the radius cubed. When we cube something, we multiply the number by itself 3 times. And when we're cubing a fraction, we can multiply the numerator times itself 3 times and the denominator times itself 3 times. So this is really like 9 cubed over 2 cubed. All right, so 9 times 9 is 81. And then 81 times 9 is 729. 2 times 2 is 4, times 2 is 8. So now we can rewrite, we have pi times 4 times 729 over 3 times 8. 4 times 729 is 2,916. 3 times 8 is 24. And then we can finally simplify this. So 2,916 divided by 24 is 121 5/10 pi. So 121 5/10 times 3.14 to approximate it is 381 51/100. And what is our units? Well, it's feet and it's volume, so that's 3-dimensional. So we have feet times feet, which is feet cubed. So the volume of this giant beach ball is 381 51/100 cubic feet. And I just wanted to show you that some of your questions that you might see in the future, and maybe they're real life questions, like you go to an ice cream shop and you're thinking about volume, or maybe they're just questions on my assignment or Mr. Battle's packet. You might have to find the composition of shapes. So this question says, what is the volume of ice cream in this cone if the scoop on top is a perfect half of a sphere? So maybe you have a full cone of ice cream and you have half of a sphere, and you would have to figure out the volume of the cone, the volume of half the sphere, and then add it together to find the total volume. So it's possible you could use all of your formulas and all of your knowledge to find multiple different kinds of shapes. All right, so just as a reminder, here are your volume formulas. We have the volume of a cylinder is V equals the area of the base times height. The area of the base is the area of a circle, so that is volume equals pi r squared h. For a cone is a third of the size of a cylinder with the same height and radius. So the volume of a cone is a third of the base area times the height. So that is V equals 1/3 pi r squared h. And looks like I forgot to put the volume of a sphere on here. So we'll just write it down real quick. V equals 4/3 pi r cubed, because the height and the radius are the same length in a sphere. So we have r squared times r, which is r cubed. All right. Some of you might try to memorize these. It'd be great for you to know them. In real life, do you really need to memorize these? Well, you'll probably be able to look up the formulas that you need. So use your formulas so that you know where to substitute your numbers correctly. Don't worry so much about memorizing these. Just apply them so that you can figure out the problems. All right, what you need to do is complete the quizzes on volume that I assigned you. Then go work on Mr. Battle's volume packet. You can join me during office hours from 2 to 3 p.m. every day, or message me if you need help. I'm happy to help you with the quizzes assignment, or help you understand the volume formulas more, or help you with Mr. Battle's packet. So please just reach out. That's why I'm here. I hope you guys are doing well. I love you and miss you. Make the rest of your day the best of your day. Bye.